Today I am going to discuss on gear drives, that is kinematics and theory of machine, module 4 part 1 PCME 503. That is part 1, classification and terminologies of gears. Now what is gear? A gear is a rotating circular machine part having cut teeth which mesh with another tooth part to transmit power and torque. Gears are used to transmit motion from one shaft to another shaft. So, in the figure 1, there are two gear elements are in mesh. Similarly, in the figure 2. Now, we will discuss number A, the classification of gears and terminologies and nomenclature and the force transmitted. Now, the classification of gear. Gears can be classified according to the relative position of their shaft axis as follows. Number one, that is parallel shaft. Regardless of the manner of contact, uniform rotary motion between two parallel shafts is equivalent to the rolling of two cylinders, assuming no slipping. Depending upon the teeth of equivalent cylinder, that is straight or helical, the following are the main types of gears to joint parallel shaft. Number 1, that is spur gears. They have straight teeth parallel to the axis and thus are not subjected to axial thrust due to tooth load, that is shown in this figure. At the time of engagement of the two gears, the contact extends across the entire width on a line parallel to the axis of rotation. These result in sudden application of load, high impact stresses and excessive noise. Now, next is spur, rake and pinion. Spur rake is a special case of a spur gear where it is made of infinite diameter so that the pitch surface is a plane, that is shown in this figure. Now, helical gears or helical spur gears. In helical gears, the teeth are curved, each being helical in shape. Two mating gears have the same helix angle but have teeth of opposite hands. So, in this figure, at the beginning of engagement, contact occurs only at the point of leading edge of the curved teeth. As the gears rotate, the contact extends along a diagonal line across the teeth. Thus, the load application is gradual, which result in low impact stresses and reduction in noise. Therefore, the helical gears can be used at higher velocities than the spur gears and have greater load carrying capacities. Helical gears have the disadvantages of having end thrust, as there is a force component along the gear axis. The beginning and the assemblies mounting the helical gears must be able to withstand thrust loads. Number 4, that is double helical, and that is also called the herringbone gear, that is shown in this figure. A double helical gear is equivalent to a pair of helical gears secured together, one having a right hand helix and other a left hand helix, that is shown in this figure. The teeth of the two rows are separated by a groove used for tool run out. axial thrust which occur in each of single helical gears is transmitted in double helical gears. So, these are used in transmitting torque between parallel shafts. Intersecting shaft. So, straight bevel gears. Kinematically, the motion between two intersecting shafts is equivalent to the rolling of two cones, assuming no slipping. The gears in general is known as bevel gears. So, in the diagram there is a diagram of bevel gears. When teeth formed on the cones are straight, the gears are known as straight bevel, and when inclined they are also called spiral or helical bevel. So, spiral and helical bevel is also shown in this diagram. In the case of straight bevel, the teeth are straight radial to the point of intersection of the shaft axis and vary in cross section throughout their length. In the case of spiral bevel gear, that is shown in this figure, from the figure it is clear that when the teeth of the bevel gears are inclined at an angle to the face of the bevel, they are known as spiral bevel or helical bevel. These are used for the driver to the differential of an automobile. Now, zero bevel gears, that is shown in the diagram. Zero bevel gear, spiral bevel gears with curved teeth but with a 0 degree spiral angle are known as zero bevel gears, shown in this diagram. So, all these are used to transmit rotary motion between intersecting shafts. Now, screw shaft. In case of parallel and intersecting shaft, a uniform rotary motion is possible by pure rolling contact, but in case of screw, that is non-parallel, non-intersecting shaft, this is not possible. Now, the worm gear. So, in this diagram, the diagram of worm gear. So, worm gears is a special case of spiral gear in which the large wheel usually has a hollow or concave shape such that a portion of the pitch diameter or the other gear is enveloped on it. The smaller of the two wheels is called the worm, which has a large spiral angle. So, these are used for transmitting motion between non-parallel and non-transmitting shaft depending on the number of teeth engaged, called single or double. Worm gear mostly used when speed ratio is quite high, that is 3 or more. Now, the gear terminology. So, in this diagram, so this is the part of the gear tooth. So, all these are shown with the help of this diagram, that is the addendum, dedendum, face, flank, face width, addendum circle, dedendum circle, pitch circle. Now, what is pitch cylinder? It is the imaginary cylinder in a spur or helical gear that rolls without slipping on a pitch plane or pitch cylinder of another gear. That is the diameter of the pitch circle. Now, the pitch circle. Pitch circle is the circle derived from a number of teeth and a specified diametral or circular pitch. when two gears run together, that one with the smaller number of the teeth is called the pinion. Pitch diameter. So, d is the diameter of the pitch circle. Now, the pitch surface. The pitch surface of a gear is the imaginary planar surface that rolls without slipping with a pitch cylinder of another gear. Now, pitch point. Pitch point, a pair of gears are operating in mesh. The point of tangency between the two pitch circle is called the pitch point. Now, pitch line velocity. Pitch line velocity is measured at the pitch line of the gear, which is midway along the length of the gear teeth. For circular teeth, the pitch line is more correctly referred to as the pitch circle, which is an imaginary circle that rolls without slipping when aligned with the pitch circle of the mating gear. Now, circular pitch. The circular pitch, it is also known as P, is the distance along the pitch circle or the pitch line between corresponding profiles of adjacent teeth. So, circular thickness, that is called T, is the length of arc between the two sides of a gear tooth on the pitch circle. So, that is P equals to pi d by T, where P equals to circular pitch, D is the pitch diameter and T is the number of teeth. Now, the diametral pitch, that is called dP. So, dP is the number of teeth per inch of diameter of the pitch circle. The unit of dP are inverse inch, that is 1 by inch. So, the diametral pitch dP is equal to pi divided by the circular pitch. So, that is called P equals to d by T, T by d. Now, the module, that is a very important terminology. So, module is the unit of size that indicates how big or small a gear is. It is the ratio of the reference diameter of the gear divided by the number of teeth. So, module of a gear is the ratio of pitch diameter d to the number of teeth, that is T. So, M is nothing but T d by T. Now, the gear ratio. Gear ratio is the ratio of the number of teeth in the gear to the number of teeth in the pinion. The pinion being the smaller of the two gears in mesh. So, gear ratio is nothing but G equals to T by small t, where capital T is the number of teeth on the gear and small t the number of teeth on the pinion. Now, the velocity ratio. Velocity ratio, that is VR, is defined as the ratio of the angular velocity of the follower to the angular velocity of the driving gear. So, that is nothing but angular velocity of the follower divided by angular velocity of the driver. So, omega 2 by omega 1, n2 by n1, d1 by d2, finally t1 by t2. So, we know that P equals to pi d1 by t1 equals to pi d2 by t2 from that. Now, velocity ratio of a gear drive. The velocity ratio is defined as the ratio of the speed of the driven shaft to the speed of the driver shaft. So, a pair of gears connected to the driving shaft and driven shaft is considered for finding velocity ratio of gear drive. So, gear 1 is a driver and which has d1, n1 and omega 1 as diameter, speed and angular speed respectively, whereas gear 2 is connected to the driven shaft. So, omega 1 equals to 2 pi n1 and omega 2 equals to 2 pi n2. Now, Vp is the common velocity. So, that is nothing but omega 1 r1 equals to omega 2 r2. So, finally, that is omega 1 r1 equals to omega 2 r2. So, putting this, so finally, the omega 2 by omega 1 equals to n2 by n1 equals to d1 by d2. So, this is called velocity ratio denoted by the symbol n. So, thank you very much.